Hi, we're coming to you as contributors to the Suricata and other open source network security projects, but most of the thinking here comes from our experience during our day jobs as Thamos Networks, where we have built a commercial network detection and response system on top of Suricata. My name is Peter Manev. I'm Chief Strategy Officer at Thamos Networks and also part of the Suricata core team.
Hello, I am Eric Leblanc. I'm the CTO of Thamos Networks, and I'm part of, as well as Peter, of the Executive Council of Open Information Security Foundation, the foundation that is driving Suricata development.
Now, folks, a couple of things that we want to talk to you about today is Suricata and SELCS. What is the relation there? Reducing the noise with metadata and classification of all those alerts that Suricata produces. What other data can Suricata produce and is useful for finding that needle in the haystack? Filter those alerts out. We're going to do a small hands-on demo to show you what exactly we mean by that with actual hands-on examples. We're going to talk about asset-oriented threat insights. We're going to talk about classification and tagging, how to further reduce the noise, and how to apply kind of what we've learned today and any additional resources for that. So, basic Suricata 101. So Suricata does live traffic analysis. It started as an IDS 12 years ago, but evolved to be something much more than that. Suricata can be deployed to sniff network traffic passively or inline as an intrusion prevention system. Suricata itself can do full packet capture and write all that to disk. Performance, Suricata performance ranges from you can deploy it on Raspberry Pi to 100 gigabit a second. 2017, we had a such test done successfully with 100 gigabit a second with Napatech. Suricata is multi-threaded. It's community-based and driven development. It's open source, released under GPL version 2. It's driven by OSF, which stands for Open Information Security Foundation. This is actually the organization behind Suricata. As I mentioned, Suricata is an intrusion detection, but can be much more than that. It's of course signature-based. It can run at full speed with 60,000+ signatures. It can use match lists. It can use indicators of compromise. It can use anything from, domain J3 hashes, any sort of MD5 SHA-SUM matching as well. You can actually hook up your own Lua scripts into Suricata for extended benefit. And really, I think basically the people that have not actually used Suricata, have not seen the type of and the extent of the data that it can produce, actually have a very limited knowledge of its power. And I'll actually let Eric talk a little bit more about the protocol data and network security monitoring part of that.
So Suricata is both IDS that Peter did describe, but it's also a really good network security monitoring. For most use case, we can state it, Suricata can replace Zeek. You have the same kind of data, you have a long list of protocols. It supports protocol from internet like HTTP, HTTP2, TLS, the old guy like FTP or SMTP, and it also supports corporate network with Kerberos, SMB, NFS, and the new stuff like IoT is also there with MQTT, and the old stuff like industrial network like DNP3, Modbus, NIP are also present. So for all these protocol, for all this application layer, like we call them inside Suricata, you can have a nice JSON formatted document for every transaction seen on the network. So you can use them for forensic, for analysis, for threat detection, for threat hunting. You can do a lot with them. So you really with Suricata, you have a combination of an IDS and a network security monitoring solution. So one thing, because Suricata is a mix, it means that we can mix both when we are doing the IDS part. So the IDS part comes with application layer metadata. That is really important because in the old days, when an IDS was triggering an alert, what we had is just an alert of this category with this name was between this source IP and this destination IP. If you're lucky, you had the port on the source port and the destination port, but that was really small. So it was not possible to really understand what was going on because the context was not there. So that's really bad. So here we can see in this alert sample that we have an alert over the TLS protocol where the second red box that we have contains all the information extracted by Suricata about this alert. So we have information about the validity of the certificate, that the not after, not before should be done below. And we have the serial version, the fingerprint, we have the protocol version. So we get a lot of information inside this alert. So it's not aggregation of event that is done in post-processing, everything is straightly out of Suricata in this screenshot. Next one. So now let's see another one, which is we see here a TLS event that contains the TLS information that we have seen on a TLS flow. So we found the same kind of data that we have seen before, but I wanted to highlight a little some little information that are quite interesting. So for example, here we see that we have the first blue box. It's an old-fashioned protocol. It's TLS V1. So it's easy to discriminate between new and old protocol. If there is security issue with TLS V1, so it's bad to have this on your network. And also what we can see is that the subject and the issuer DN are equal, which means that it's a self-signed certificate. So it's not a valid certificate authority. It's not secure. So we got a bad protocol and an unsecure certificate on this flow. So that's something that is really suspect. Next one. Yeah, next, Peter. Okay, so let's take another example, which is this time an alert on Peter. I see your screen when you do that. So I've got an alert on HTTP protocol, and here we see a lot of information that help you to understand what is going on. So okay, so we don't even need the information about the alert. There is an alert, but let's look at what we have inside the HTTP. One of the first things is the first blue box. It's the host name. We see that the host name is directly an IPv4. So it means that the user did connect through this system, through this website, by typing the IPv4 address. And what we can see also in the line below this first blue box is that the status is 200. And we also see a little bit below that the HTTP method is post. So we got a post on an IPv4 address. And what we can see in the answer, which is the HTTP response body printable, is that we got the standard default web page. It works. This is the default web page. So just by seeing this, we see that we have indeed something that looks really bad because we have an alert on the context that we have about the alert show us that this is really strange. And if we look at the URL admin get.php and then the HTTP port, which is 443, we've got a lot of bad stuff just by looking at this HTTP information that complement the detection that has been done in the alert by the detection engine inside Suricata. Next one. Okay, but all this information that we have seen previously in the previous slide were about the information that have been extracted by Suricata in the application layer analysis engine. Here, what we have is information that comes from the signature. There is the keyword that is metadata, it is used frequently in the signature, that allow you to define key value, put value inside, and then it can give you context about what the signature match was about. So here we got two important, really important things is the affected product. So we see that the targeted product is in fact Windows XP and below, which is, and that was the first metadata. The second metadata is really nice, which is the malware family. So it means that the alert was targeting the TrickBot malware. So it was trying to detect the TrickBot malware. And then we got two other information that can be really useful. It's the created at and updated at. Updated at will tell you that the signature has been updated quite recently. And the created at, you will know that this threat has been found on a signature has been written on this day. So if you want to focus on the recent fields, which is usually the most active thread, you can use this as a classifier to say, okay, maybe I should look first at the recent created ad because it's the fresh stuff that maybe my anti-malware solution, my EDR solution is not ready for.
And kind of a few words about the open source SOCs, and that actually it is developed by Stamps Network. SOCs is a turnkey Suricata-based IDS, IPS, NSM ecosystem with its own graphic rule manager and basic network threat hunting capabilities. SOCs is Debian-based live distribution built from 5 key open source components that comprise its name. So this is Suricata, Elasticsearch, Logstash, Kibana, and Stamp Series Community Edition, which is used for Suricata management and Suricata hunting. In addition, it includes other components such as Moloch and Evox, which were added actually after the acronym was established, but now a part of SOCs. SOCs is a contribution made by Stamps Networks to the open source community. It's freely available, and it's released under GPL version 3 license. So the source, the README, the issue tracker, and the wiki can be found on GitHub as github.com/StamplesNetwork/SOCs. Let's talk a little bit about the challenge. The challenge is obvious, typical day at the SOC involves, hundreds of millions of events in anything from medium to large enterprise. So all these things need to be taken into account. You have a lot of data. Where do you start for? What do you do with it? So that always is the challenge. And in this case here, we'll be talking about Suricata data produced by Suricata, alerts, protocol data, and so forth, and how to best tackle with it. At least some examples of how to do it. So the first thing you can do is basically, of course, use some filtering. So select alerts by way of filtering them based on metadata from that alert. So actually use filtering methods to limit the number of alerts to investigate, to concentrate on. Usually Suricata generates a bunch of alerts, use them as context, and actually make sure you know which components of the alert metadata actually are valuable. So, for example, don't use severity because actually it could be misleading. What's a bigger severity category for my network, for my organization? Network might not necessarily be that severity for your organization or for your network. Rule writers, no rule writers use it and set it, especially having in mind that there's different sources of rule set providers, for example, nowadays. The default value is actually critical when you use severity. But let's have a look at a couple of complementary approaches that we can try out. So classification base and hunting approach. Okay, so classification base is actually zoomed in on involving some sort of filter set, rather to filter out and classify, let's say, events, whether it's CNC or malware, select kind of the more important or the real threats, the more important events or the real threats. And then the hunting approach is, for example, increase your pace, increase your odds at defeating the adversary by investigation priority of alerts by combination of factors. You combine different things together, and that formula actually results into something more relevant to investigate. So let's have a look actually at I would say 3 such examples, some hands-on. First, we're going to use the Series Community Edition and then Kibana queries. And 3 small, very simple examples just to emphasize the point of the different angles you can take when you're actually hunting. So the first concept is like filter out the noise, active hunting, discover unknown threats by way of filter sets with the Series Community Edition. And the other approach would be actually hunting queries by application layer protocol. So not alert events related whatsoever. Now, let's go onto the live demo. I'm going to share my screen. Let me see. I'm going to do desktop too. Do you folks see my screen?
We currently see the slides. And
Okay.
now, yes, we see the browser.
Now it should be better. Okay.
Yes.
So what we have here is actually the landing page of Ceres Community Edition. We have a switcher up here from which I'm going to jump into the hunting application right in here. So this hunting application actually will be a way of using the filter sets as an example, and we're actually will be doing active threat hunting on alerts, let's say. There's a couple of filters that I'd like to show you. The first one is actually very simple. It's called TLS old version. So basically what it is saying, we're actually saying, show me any TLS protocol-based alert event, but where the TLS version is older. And as you can see, this is a simple query. It returns about 160 results. It immediately zooms into that. And the purpose of it actually is just to show older TLS non-secure versions. And so let's go ahead and actually have a look at one such alerts and see what it shows. So we have an example of an alert here. We have the extra TLS protocol data in there. We have a payload printable. We have the signature ID, and we actually have the raw log itself. So in here, this is actually in JSON format. So in here, we have any and all information about the alert. And as we can see, we were actually looking for all the TLS versions, and that's why the result that we return, we have this alert included in there. And you can see by the subject and the issuer that you have additional information there, but it's very, very low, old rather version of TLS. Now,
yeah, Peter, just can you scroll down? That's quite fun.
Yeah,
if you
sure,
check the end of the expiry of the certificate, it's valid till 2044.
Yeah, it's a bit of a long time.
Yeah, when you consider that usually 1 year is already long, for a few years, maybe that's huge.
You know, in a company with a GMO, there's a lot of things we can hang on here. Yeah, absolutely. So the second filter set, let's say another filter, another perspective, another zoom in would be actually, let's say, hidden executable. So what does this mean? Actually, the filter itself is kind of self-explanatory, very, I think very obvious. So basically, we're looking for HTTP content that says it's an image, right? But it's actually an executable. So hence the name of it, hidden executables. And what does this
Okay, so
you want to have a look at the alert? Yeah, sure, go ahead.
No, Peter, we lost you for 10 seconds. So if you can just start from the point where you were saying that just after the beginning of the explanation, that would be nice.
Okay, right in here. So here we have, apologies. So here we have another perspective of that filter set. It is basically a little bit self-explanatory, I think. We're looking for HTTP content that advertises itself as an image, but it is actually an executable. And the filter here immediately returns 20 results for such events. Again, we don't really care about MD5s, red listed or white listed events. We just say, give us images that are advertising, give us files that are advertising as images, but they're actually executable. And actually, if you zoom in on and have a look at some of those examples, when we go into the alert tab, these are actually fetched, all the logs in here. And let's have a look at the first one. And as you can see here, we have the metadata, which is quite revealing. Basically, it's saying that we have a WinPNG advertising as a content type image. We have a payload printable and HTTP response body, but if we actually go to look at the related events, we can see that this is actually a file. It's called win.png, but it's actually an executable, and this is actually the file transaction, the file information log with checksums, with its magic, and so on and so forth. We have the related HTTP request that actually provides further evidence for where was this downloaded, was it successful, we know the content type, methods, and similar. And of course, the conversation that triggered that alert also triggered 3 other alerts. And here is all the data, the file transaction, the HTTP log itself. Just a quick, simple example of how powerful filtering on metadata can be. What I want to show you is a third example. We will actually quickly jump over to dashboards in Kibana. So the hunt, the Sirius Community Edition is actually a hunting interface based off and displays data based off alerts and alerts metadata. Here, I would like to actually show you file transactions. So basically, this is not alerts. This is any file transactions on the network. Suricata is capable of actually extracting that information from protocols like HTTP, FTP, NFS, SMB, SMTP, and similar. And here I've actually prepared a simple query. Yeah, go ahead.
Yeah, and something we did not mention yet is that we can extract this file on the disk. So you can have a signature that when it matches, extract the file on disk, or you can directly say inside Suricata, every time you see a file, you extract it to disk.
Absolutely, thank you. And here in this case, we have a dashboard actually displaying all the information, any and all files, regardless of, so for example, here we have HTTP and SMB application layer protocols that we've seen file transactions from. We've created a simple query in here. So what we're going to do is actually activate it. Basically, what it says is we're saying from protocols like FTP, SMB, HTTP, NFS, and SMTP, please show us executable types that are actually very long in terms of name. Just a sample query, okay? You'll be surprised by the results. So as we scroll down, we can see the results, and we have 4 such transactions, and you can actually see that the names are quite unusual. So if we look at one such transaction, we can see this is a file name of an executable. It's unusual to have that name. It's a bit long and kind of non-logical, to say the very least. We know that it's an executable, and actually, as we scroll down, this is pure protocol data. So this is nothing to do with alerts. We can actually see that this is a SMB log. It's a write, and basically, it's writing from this source IP to 505. And actually, this name is unusual, so we have a SHA-250 fixed checksum. We can click on it. That will bring us to VirusTotal. And what do you know? In this case, this one was actually red listed here in VirusTotal. So again, this is just an ad angle. This is just an idea, but it's not based on alerts. This is just entirely searching queries based on protocol data. In this case, SMB. So those are 3 examples that I wanted to show. Let me go ahead and reshare my slides now. Here is another example based on filter sets. So in this case, we are actually filtering out by category. In this case, it's called malware command and control activity detect. Simple, but yet it can zoom out from 1 million to 10 events type of thing. So you have to combine all these. There is also a different perspective. This is just the one that we demoed. So an executable advertising itself as an image, really simple. This is an interesting one. This is basically what it comes down to. Is very simple. HTTP request or replies to just a public IPv4 address. Usually, you use some sort of a domain, not actually the actual IP, but it can return actually interesting results for investigation, regardless of source destination or the name of the alert. There's another example here that we actually, similar to what we covered, older versions of TLS. If you have security events, security alerts that are triggered by unsupported TLS protocol versions, let's say. And that's an interesting one. Actually, here we have basically we're saying, give us HTTP protocol that actually are, and we're looking for the word root inside the payload or inside the packet rather. So that could return interesting results, believe it or not. So a different angle. And Eric, back to you. Wire filtering is great, but it has challenges. What do you say?
So what Peter did show you currently is a great practice for threat hunting. But there is one step missing, is that if you have to do this work of discovery, redoing thing every day, even if you have a filter sets, you will need to go over all the filter sets one by one, and it may not be the most efficient way to directly jump on the new things that did happen in your network, the new alert that really need to be investigated. That really need investigation, sorry. Peter, next one. So one possible approach to fix this issue is to simply tag the event. Tagging the event is really something that you need to do because in fact, you don't want to suppress the event, because if you suppress the event, you will lose some context that can be really interesting in some case to discriminate, to combine in the search, to do the threat analysis. So try not to suppress, but use a tagging mechanism. So to do a tagging mechanism, there is some simple possibility. If you are using something like Elasticsearch, you can do queries and update the data inside Elasticsearch. You can also work on the output of Suricata with some post-processing to do the filtering. But what is really important here is that if you look at what we have shown you since the beginning, you've got the metadata coming from the signature, the metadata coming from the application layer, and both of them are really valuable source of information when you try to analyze and when you analyze the alert. So usually when you are doing this work of analyzing the alert, you will see that this combined to this is in fact meaningful for you. You know that if it repeats itself, you will have something that will still be interesting. Or reverse, if you have this and this combined, you know that it will be always with information with regards to your network. So one of the best ideas you can have here is to combine this information. Every time you've got this set of criteria, you build the rules that will tag the event as relevant or as informational. It will allow you to update the daily job. First, you check the relevant because you know that's possibly some bad stuff that are coming back. Then you investigate, you look at the things that you don't know, and you do the classification. So this way you have something that you have less work to do, less work to focus. You just have to focus on what is relevant, what is unknown to do the classification, and on the incident response itself, you need to look at that too. Next one. So this approach is really nice, but it has some limits because, for example, if you take one signature that detects a command and control beacon, but this command and control beacon can hit every 5 minutes. So every 5 minutes, you will have a new alert to investigate. So at the end of the day, you still have a lot of alerts to investigate. So let's take a step back on what we really have. In fact, when we are doing what we are trying to defend our organization is to find if we have asset at risk, an asset that is potentially infected by a threat. So what will be ideal here is to be able to see, okay, I've got some signature, I've got some event, I've got some alerts. I want to come from these alerts to the list of assets that are potentially infected by a threat. This will be really useful because it will allow us to limit the noise about alerts that are repeating themselves, and it will give us a clear view of what is happening on the network. Next one. So I was asked this question long ago, and it was quite a problem, in fact, because if you need to answer to the question, give me the list of assets or the list of attackers in one network based on the alert event, it's in fact not written. It will be for sure the source or the destination IP, but you don't really know which one it is. For example, if we take the first one, which is the scan, the packet coming from the attacker going to the target. But if you look at the second alert, second signature, sorry, in this case, it checks that the answer is the answer to an attack. So in fact, the source and destination are reversed with compared to the source and target of the attack. So you cannot find easily the asset. You cannot say the asset is always the source IP in the alert. That is not working, and it's not ever true for the destination IP. So you need to improve that. Next one. So that's something I did introduce by adding the target keyword inside Suricata in 2016. And it's just a simple option that you add to the signature to say that the target, so the asset, is the source of the destination IP in the signature. So by doing this, we can have clear information about what's going on. Next one, please. So what do we have? When we have this keyword inside the signature, it creates alert.source and alert.target subobject that contain information about the IP on port of the source on the target. And by doing this, if you want the list of the asset and detected by the IDS, you just do alert target.ip and then you get this list. Before it was not doable, you have some inversion to do manually, so it was really a pain. So with this keyword, you fix the problem. So sadly, not all the signature contains the target keyword. So if you can put pressure on, for example, Proofpoint, so they add the target keyword to their rule set, which is ETPro, that would be, or on ETOpen, that would be really nice. As a result, we have introduced in Serious Community Edition, so in sales, an heuristic on some algorithm to manually determine the value, and you can also do that manually so you can get to the result. So next one. So what is the result? The result is that it becomes obvious to get a clear view of what is happening on your network in terms of threat. So here we have a simple Kibana queries that display a table. The first column is the target IP, so the list of assets. And the second column is the malware family, one of the metadata that we have seen at the beginning of the presentation. So by combining this in one query, we have the list of two assets on this network, that the 5.5 and the 5.101, that have 3 threats, and the other one has something like 5 threats seen on it. So we get a clear view of the threat present on the network on my asset in one single query. So that's really a simplification. Even if, for example, the TrickBot detection is CNC, we will just have one information, and then you can also combine with first seen, last seen by doing more advanced query that we are not fitting on the slide deck. But you can do really better things doing that.
Sorry, thanks about that. So as you're mentioning, Eric, it's actually it's a repetitive process, but the repetitive part you need to actually automate, and you can automate so that you have to, you can look at less and more relevant stuff. The challenges of relying on just signature metadata alone there's a few, of course. The classification can be complex. It requires some signature writers to insert the source and target keywords when writing the rules. Some signatures will only identify possible threads, so it might not be so useful there. There's a variety of signature sources, all sorts of providers. So basically, you need to actually, it's a repetitive process. The signatures are updated daily in a lot of cases, so you have, as I mentioned, different providers. So you have to actually, it's something that you have to do repetitively in high pace as well. So you have to review the sources, the information that you get from there, update the signature content, see if you have to update anything in the process in there, and then push it out to the sensors. And that's repetitive. That has to happen on the fly and in a rapid fashion, whatever needed, to stay in pace. So it's a process that you need to, once you do a couple of times, you can automate. Yes, go ahead, please.
No, we need to hurry up.
And so Stambus Network's open source contributions. Well, actually, Selks is one of them. It's actually open source Suricata turnkey distro. Actually the first one out there that is entirely bases information on Suricata data alone. We have GopherCap as well, open source pickup playback tool that you're more welcome to read online on GitHub. The information in there comes really handy when you need to replay multiple sorts of different pcaps just as they appeared on the network, as they were captured with the timestamps. We also have the Stamos Network Splunk app that is free out there for use. All that information you get on the stamosnetwork.com. We are actually we're believers. We're defenders. We're believers that defenders are heroes, and actually we believe in a future where those they protect remain safe. Okay, so we just wanted to share some of the open source tools and processes and tools that we actually do daily at our jobs. And so apply what you've learned today. First of all, identify filter sets and queries that yield interesting results with respect to your setup, your organization, let's say, that you're doing security monitoring. There is no golden bullet, one fits them all. You have to actually identify those, what filter set queries actually yield most interesting results by the data provided by Suricata. The next step will be understand better the relationship of the results and these hunting queries. You know, you'll learn as you go, and that's quite normal. You always learn in a new environment, and every environment is different. And invest time into automating the different aspects of it. So once you do it manually and you're happy with the research and the results of the research, you know then actually what exactly is repetitive and it could be automated. Begin establishing a hunting process based on the lessons learned. So I also believe strongly in active threat hunting. You know, go a little bit on the offensive. Don't just be reactive. Go proactive if possible, of course. And then the last step will be like, of course, improve the current posture by implementing those noise reduction processes above. Drive a project to improve the security monitoring with all the lessons learned. Implement all the automation. Automate only once. And then automate a different idea, different process. Don't automate the same thing over and over again. Eric, what shall we say? Suricata formulas, all our data comes from Suricata in the demo and in our daily work. You have the links right there on the screen. Eric, is something I'm missing? Or
no, I would just say that if you want a quick grasp about what we have shown, it's really fast to spawn up a sales instance on the network. It's just a few minutes before you get the first meaningful data. So that's worth a good try. And if you want some documentation or some training, you've got the forum for Suricata and you've got the Suricata IDS training done by the OISF. I think that's all. And
there's plenty of data in the forums and discussions, by the way, because you can reach out to power users and regular users, and you might ask a question that probably somebody already has an answer for. So don't be shy. Thank you very much to RSA conference and to all the defenders there, and thank you very much for open source and all the people that are actually sharing to others, at least on my part.
Thank you.